Today we're going to look at lesson 7.4, which is about division property of exponents. So that's our objective. I can use the division property of exponents. All right, so it says dividing powers with the same base. So let's think about this. Let's think about x to the fifth divided by x squared. Okay, so notice that we've got x to the fifth, x squared. They both have the same base of x. Let's talk about what it means when we have x to the fifth power. Remember that exponent of 5 tells me that I see that base x 5 times. So I'm going to write it out as repeated multiplication. Same idea in the bottom. If I have x squared, that means that I'm going to have 2 of the bases of x. So repeated multiplication. Notice that with division, if there's something in the top that's also in the bottom, they divide. Like think about dividing the number 4 divided by 4. Well, if I have 4 and I divide it by 4, 4 divided by 4 turns into 1 because essentially they cancel each other out. There's still something there. It's really the number 1. So same idea here. If I have an x on the top and an x on the bottom, they're going to cancel out, essentially turning to the number 1. Same thing here, x on the top, x on the bottom. I've run out of x's on the bottom. I've got 3 x's on the top. So writing that then back into an exponential form, I would keep the base of x, and there are 3 of them. So the question is, what did we do with the exponents? So once again, our exponents started as the numbers 5 and the numbers 2, and we ended up with the number 3. Hopefully we are aware that 5 minus 2 will get us that number of 3. We subtract it. All right, so let's take a look at our formal definition then. It says to divide powers that have the same base. We are going to keep the base and we are going to subtract the exponents. Okay, so if we had something like x to the power of m divided by x to the power of n, because they have the same base of x, I keep that base of x, and then I take m and divide it by n. Notice that technically then I don't have a fraction anymore. When I do that, it's technically all over 1, which is why we don't normally write the fraction. All right, so with that information, let's take a look at some practice problems. We've got 8 to the 6th power divided by 8 to the 4th power. Notice that they share the same base of 8. We are dividing, so like our definition up here says, we are going to keep the base and we're going to subtract the exponents. So I keep the base of 8 and I take 6 minus 4. It's always the top exponent minus the bottom exponent. Think of that division sign as a subtraction sign. So that's why it was 6 minus 4. Once again, it's technically over 1, so everything's in the numerator, which is why we don't even have to write the fraction. So we have 8 as the base, 6 minus 4 is 2. Because it is a squared term, we can go ahead and we can actually multiply that out. Remember, 8 squared is really 8 times 8. So in this case, this would simplify to the number 64. In the second example, we have y squared divided by y to the 7th. So they have the same base, which means that I'm going to keep that base of y and I subtract the exponents. So the top exponent was 2 minus the bottom exponent, which is 7. Once again, it's technically all over 1. That happens in the numerator. If I subtract, 2 minus 7 is going to give us -5. Notice that negative exponents I cannot have for my final answer. So that's why thinking of it as over 1 is going to be important in this case. Because my exponent that's negative starts on the top of my fraction, we're going to have to move that term down to the bottom to get that exponent to be positive. Because there's no other terms on the top, that means we get to write a 1 on the top. The y gets to move down to the bottom, which then changes that exponent of 5 to a positive. So my answer is 1 over y to the 5th power. If I look at this next example, x to the 16th divided by x to the 16th. Well, they share the same base, which means that I can write the base of x. I keep that the same. Now, because we have a division problem, I'm going to subtract. The top exponent is 16 minus the bottom exponent, which is also 16. Notice that 16 divided by 16 is 0. This is not my final answer because if we think back to the very first lesson that we had, anything raised to the power of 0 is going to become the number 1. And hopefully that makes sense. Think about it. X to the 16th divided by x to the 16th is the same thing. It's just like me talking up here when I said that 4 divided by 4 was 1. If you're dividing the exact same thing, it turns into the number 1. Well, x to the 16th power is the same thing on both the top and the bottom, and that's why my answer is 1. Let's take a look at the second thing called raising a quotient to a power. So let's think about in parentheses a over b, so a divided by b, and I'm raising that to the 3rd power. Okay, because a divided by b is in parentheses, since it's being raised to the 3rd power, I know that I'm going to keep the parenthesis exactly how I see it, but I'm going to have to write it out 3 times because that's what my exponent is. Because now we have essentially a multiplication problem, because we're dealing with fractions, when we multiply fractions, we multiply straight across. So all of the terms in the numerator get multiplied together. So that means that we have a times a times a. In the bottom, I get to multiply those denominators together. So that's b times b times b. Notice that if I was to count up, since I have the same base, I've got 1, 2, 3 a. So really, this is a to the 3rd power. Notice that in the bottom, I have 1, 2, 3 b's. So I have b to the 3rd power. Notice that what the answer is that I got right here happens to be very similar to the fact that since a was raised to the 1st power and b was raised to the 1st power, notice that they're raised to the 3rd power, a power to a power. This takes us back to the last lesson that we did. A power to a power means that we are going to multiply. Notice that the exponents got multiplied together. 1 times 3, that's why now there's a 3 on the top with that exponent. 1 times 3, that's why there's a 3 on the bottom with that. So here's our formal definition. To find a power of a quotient, and quotient means division. Oops, gotta spell that right. To find a power of a quotient, we are going to find the power of the numerator and the power of the denominator. Okay, so if I have x to the power of m divided by y to the power of n, and that's raised to the power of p, I'm going to keep the base of the numerator, but I multiply the inside exponent times the outside exponent. Keep the base of the denominator, multiply the exponent on the inside to the outside exponent. Okay, so let's take a look at some examples. So notice that what I have in parentheses, 4/5, we've got two different bases here. Notice that the first thing I'm going to do is I'm going to identify what are the exponents inside these parentheses. If I just see a 4 and I don't see an exponent, it's really to the first power. If I see a 5 and I don't see an exponent, it's really to the first power. So notice that we have exponents on the inside, exponents to the outside. We have a power to a power situation here. So I'm going to keep that base of 4, but I multiply its exponent of 1 times the outside exponent of 3. Same thing on the bottom. I keep the base, then its exponent of 1 gets multiplied by the outside exponent of 3. So 1 times 3 is 3, so we have 4 to the third power. 1 times 3 is 3, so in the denominator we have 5 to the third power. Because these are raised to the third power, I think that it's easy enough for us to use a calculator. Remember, 4 to the third power would be 4 times 4 times 4. So if we calculate that out, 4 times 4 times 4, we'd have 64 on the top. On the bottom, we have 5 times 5 times 5. So use a calculator, and we get 125. And this would be my final answer. Okay, if I look at the next problem, we've got 5 over x to the 5th. So two different bases here. Once again, I want to make sure that I know what the exponents are for each of those bases. With the 5, I don't see an exponent, so I'm really going to put a 1 there. With the x, we already have an exponent of 5. Both of these things are being raised to the second power. So remember, that means I keep the base, and its exponent on the inside gets multiplied by the outside exponent. Same idea with the bottom. I keep the base, its exponent on the inside gets multiplied by the outside exponent. So on the top, 5 is now raised to the 1 times 2, which is 2. On the bottom, x is raised to the 5 times 2, which is 10. Once again, because we have a number for our base on the top and it's an exponent of 2, we can very easily multiply that out. 5 squared is 5 times 5, so that would be 25 on the top. We have x to the 10th power on the bottom. No negative exponents, so that means that this is my final answer. And then in this last example, we have a y divided by x. So we've got two different bases inside parentheses being raised to the negative 4th power. So I'm going to identify the exponents inside the parentheses first. Well, y doesn't have an exponent, so there's really a 1. Same thing with the x. So remember, I keep the base of y and I multiply its exponent with the outside exponent. Same thing with the x. I keep the base, its exponent on the inside gets multiplied by the outside exponent. Well, 1 times negative 4 means that we have y to the negative 4th on the top, and on the bottom, x is now raised to the 1 times negative 4, which is negative 4. Notice that I see negative exponents, which means that this cannot be my final answer. Exponents that are negative on the top means that that term needs to move down to the bottom. Exponents that are negative on the bottom means that they have to move up to the top. So in this problem, we are essentially flip-flopping. The x now is on the top, which changes its exponent to a positive 4. The y gets to get moved down to the bottom, which changes its exponent to a positive 4. Now we have positive exponents. The bases are different. This is my final answer.